So we were doing the conservation of linear momentum. Now I am giving you one illustration. Suppose there is a boat and there are two persons of mass m and the mass m's are rest. Are you getting or not? This is A, this is B, and the boat of the mass m. Right. First person A jumps. Person A jumps with velocity in this direction, with relative velocity, with velocity u, relative to the boat, right? Initially the system is at rest, right? It is at rest, and then person B jumps with velocity, with same velocity u, right? Relative to the boat. So you have to find the final speed of boat. This is the question. Copy this. So how to solve this question? Listen one thing. I'm writing the solution. Try to understand. Right. Suppose initial momentum is what? Say 0. Then there are two persons of mass m and m. When the first jumps in this direction with the speed, relative speed u. Are you getting? So what will be the movement of this boat plus person? It will be moving backward. This is capital M, this is small m. Suppose it acquire the speed v1, right? And this person m move with the speed v2. This is the figure with respect to ground. Are you getting or not? Also, this is the figure with respect to ground. Is it clear or not? So if this is moving with v1 and v2, what is the u? What it is the relative velocity. Can you tell me the relation between v1 and v2? Yes, v1 plus v2 is equal to what? U. And the another relation, m plus m into v2. So we have to find first v1. So what is the value of v2 over here? v2 is u minus v1. I will put the v2 value over here. This is m into u minus v1. This is m plus m into v1. So when you will simplify, the m plus m v1 plus m v1 is equal to m into u. So after first person jump, the m plus 2m into v1 is equal to m into u. So the boat will move in the backward direction with the speed this much. Are you getting or not? First copy this. So listen one thing. When it acquired the speed, the cart, this acquired the speed v1 of mass m, right? And this is the mass m. So now before jump, this is the initial momentum of the boat plus man system. Now if he jump in this direction, so what will happen? The boat speed will be v2. Is it clear or not? Suppose this is v1 dash. So you tell me v1 or v1 dash will be greater if this person jump with the speed, suppose v3. Are you getting or not? So this is the capital M, all right, and v3. This is the figure with respect to ground I am making, with respect to ground, and this figure is also with respect to ground I am making, because I have to conserve the momentum with respect to ground. So you tell me v1 and v dash, v1 dash or v1, which will be greater? v1 dash. And what is the relation between v1 dash and v3? U, because the person B of mass m jumps with respect to boat with relative velocity u. So therefore, the v1 dash plus v3 will be equal to u. We have to find this. So therefore, the v3 value will equal to v1 dash. Is it clear or not? So now, if you think, what is the initial momentum? If you assume this is the positive x direction, can you write the initial momentum before jump? M plus m into v1. But if you take this negative direction, it is the negative direction. Right? Are you getting or not? What is the final momentum before after jump? M v1 dash plus m v3. You tell. Now, conservation of linear momentum, pi is equal to pf. The initial momentum is m plus m into v1. Final momentum is minus m v1 dash plus m v3. But I have to eliminate the v3. So minus m v1 dash m u minus v1 dash. Right? And what is the value of v1? It is the value of v1. So here minus m v1 dash plus mu. So we have to simplify this. Minus m plus m v1 minus mu is equal to minus m plus m into v1 dash. The minus will cancel out, right? So the v1 value I have to put. Minus will cancel out. It is m plus v1 plus mu is equal to m plus m into v1 dash. When you will divide m plus capital M, so it become v1 dash. So this is the v1 dash we have to find, right? So when you will simplify, divide by m upon m plus m into u is equal to v1 dash. What is the value of v1? The value of v1 is mu upon m plus 2m, right? Mu upon m plus m is equal to v1 dash. So when you will take the LCM, right, this is mu common, the LCM is m plus small 2m, right, and this is m plus small m plus 2m is equal to v1 dash. This is 2m is equal to v1 dash, right? So this is mu upon m plus 2m, 2 capital M, 3 small m into v1 dash, right? So we do the next question, and in this example, suppose we have a trolley of mass 220 kg, suppose, and a person of the mass 30 kg is on the over of this car, and it is moving with the speed 20 meter per second, right? So this is the question. Now if boy jump from the trolley, if boy jumps from trolley, there are two cases. First, he jumps from the trolley in the direction of the motion, in the direction of the velocity, or opposite to the direction of velocity. First, in the direction of trolley, right? And the second part, in opposite to the direction of trolley, opposite to the direction of trolley. All right, this is the question. With velocity, and the velocity is 10 meter per second, right? Find speed of the trolley, after jump. So this is the question, right? So in this case, although this is the initial momentum, first case in the direction of the trolley if the person jump with the speed 10 meter per second. So this is 30 kg and the speed of this trolley become v dash. All right, v dash. So in this case the initial momentum, in this case the final momentum must be 0, right? Although it is not given in this question that it move with the speed 10 meter per second with respect to car. This is the velocity of the person given with respect to ground, you will assume. So the initial momentum, final momentum you have to make equal. The initial momentum 20 plus 30 both are moving with the speed m1 plus m2 into v1, and here this is the momentum, final momentum 30 into 10 plus 220 into v dash. So this is 250 into 20, 300 plus 220 into v dash, right? 1 0 will cancel out. This is 500 minus 30 is equal to 20 v dash. So v dash is equal to 470 upon 20, 235 upon 11 meter per second is the velocity. Is it clear or not? Yes. In the second part, if this is the car moving with 220 kg, after velocity it become v dash. But now this is the 30 kg person move in this direction with 10 meter per second. So here the final momentum you have to take. So the P final, the final momentum 220 into v double dash minus 30 into 10. You can simplify this into 20 is equal to 220 v dash minus 300. 1 0 I will cancel. So this is 500 is equal to 22 v dash v double dash minus 30. 530 is equal to 22 into v double dash upon 20. So this is 265 upon 11 meter per second is the velocity of this car, after he jump opposite to the direction of the velocity. Copy this. So in continuation with this, I take another example. This is the block of mass capital M and the bullet of mass M is moving with the speed u, and after hitting this block the bullet embedded in the block, right? And then the both move together, so you have to find first the common velocity, the second is the loss in the kinetic energy, right? So this is the question. So how to do this question? First question, the initial momentum, suppose this block is at rest, the initial momentum, and when after embedded it, this bullet and the block system move with the, this is M and this is the capital M, the final momentum it will have. So the conservation of momentum we will apply. This is mu plus m into 0 because it is at rest and its momentum is mu. Now both are moving with the common velocity, right? Capital M plus v dash. So what is the common velocity? It is 0, right? So mu is equal to what? M plus m v dash. The common velocity, the v dash, will be equal to m upon capital M into u. This is the common velocity. The second part, the loss in kinetic energy we have to find. So high loss in kinetic energy, right, is equal to initial kinetic energy, it has the 0 kinetic energy, minus final kinetic energy. This system of blocks and bullet are moving with v dash, half m plus m v dash square. So half m u square minus half m plus m. This is the value of v dash, u whole square. If you take common half m u square, here only the 1 will left. From here it is the square, 1 power will cancel out, minus m into m upon m plus m. It will left. You can simplify it. Multiply minus m upon m plus m. It will cancel. So half m u square capital M upon m plus capital M. So the loss in the kinetic energy is nothing but m upon m plus small m into half m u square is the loss in the kinetic energy. Is it clear or not? Copy this. So we do one more question for the conservation of momentum. Suppose there is a block hanging with the string of length L, right? Initially it is at rest and a bullet is coming of mass m with the speed u. Bullet is embedded in it. When it embedded in it, right? So after embedded, the bullet and the block system will acquire some common velocity, and because of this common velocity they move together up to some height h. Is it clear? At the maximum height the final velocity becomes 0. So you have to find the height rise by this block and bullet system. This is the question, very general question. So in the initial and the final momentum we can apply conservation. So m into u plus capital M into 0, it is the initial momentum. The final momentum, both block and the bullet are moving with the common velocity v dash. So mu upon m plus mu is the v dash. So this is the common velocity, right, with which it will move together. And if we take the reference, now we can apply here the h is equal to 0 at point A to B, when it will rise to some height h. So this kinetic energy at A, potential energy at A is equal to kinetic energy B plus potential energy at B. We can apply conservation of mechanical energy. Here h is 0, so initial potential energy I can assume to be 0. This is the initial kinetic energy, right, is equal to final kinetic energy become 0. The potential energy is what? M plus m into g into h. The m plus m will cancel out. V dash square by 2 is equal to gh. V dash square is equal to 2gh, right? And this is the v dash square. V dash is nothing but m plus small m into u, right, ka whole square is equal to 2gh. H is equal to m square u square upon m plus m whole square into 2g. So the height h is equal to u square upon 2g into m plus capital M small m whole square. So this is the maximum height raised by the bullet plus block system when it start moving with the common velocity. Copy this. So in the next illustration, continuation of linear momentum conservation. Suppose there is a bullet of mass m, it is moving the speed v. Now it does not embedded in this block system, rather it after penetrating the block it acquires some velocity v dash, which you have to find, right, such that if this is the capital M block, it initially it is at rest, but when the bullet penetrated, and the some momentum is acquired by this block, and because of this it raised to some height, all right, and this height raise h is given in the question, right, and you have to find the speed of the bullet after penetrating this block which is at rest initially. So the mass m is the 20 gram of the bullet. Initial speed, this is the u naught, suppose 1000 meter per second. The block mass is 1 kg. All right. Find the speed with which bullet come out from block. This thing you have to find, right? So I'm writing the solution now. This is the question. First of all, you must understand this. This height is also given in the question. The height is equal to what? Say the 1 meter. The This height is 0.2 meter. Height is 0.2 meter. So first from point A to B, right, final speed is 0. Suppose the speed acquired by this block when the bullet penetrated is v dash. So first we will find this speed of the block v dash. How to find? We will apply for block apply conservation of energy, that is this kinetic energy is converted into mgh. Will cancel out, v dash square is equal to 2 into g into h, 2 into 10 into 0.2. So the v dash is equal to root 4 is equal to 2 meter per second. So the common velocity is v dash is equal to 2 meter per second. All right. Now the initial momentum before penetrating this is equal to final momentum. The initial momentum is m into u naught plus capital M into 0. But after, when it penetrates, the bullet penetrates the block, the momentum achieved by the block is mv dash n. Sorry, this is the v we can assume. Okay, this is the v dash and this is the v double dash you can assume. So we have to find the v double dash, the velocity of the bullet after penetrating, m into v double dash. This is 0. What is m? 20 gram. What is the velocity? 10 ki power 3. This is the speed, 10 ki power 3. Capital M is 1. V dash is what? Say 2. 20 into 10 ki power minus 3 into v double dash. This is the mass of the bullet, 20 gram. Right. So this is 20 is equal to 2 plus 20 into 10 ki power. Simplify this. 18 upon 20. 9 upon 10, 900 meter per second is the speed of this bullet when it penetrates the block. After the penetrating, it acquires the 900 velocity, 900 meter per second, while initial velocity before the penetration it is 1000 meter per second. You can also find the loss of the kinetic energy in this case. What is that? Half m v dash square minus v double dash square. Initial velocity is more, the final velocity is less. Therefore, when you are finding the loss, initial minus final kinetic energy, you have to take into account. Right? Copy this. Now we will do a very important and interesting question. It is, suppose there is a wedge who is in this shape, and it is the semicircular track. Right, the quarter circular track of the wedge, the mass is m, right? It is placed on a smooth inclined plane, a smooth surface, and there is a small block of mass m. The radius of this circular track is r. So when it is released from rest, so what will happen? It will come down. So when it will come down, it acquires the speed in this way, right? So when this is the horizontal track, this m, the mass, when it comes down along the circular track, it acquires some velocity and acquires some other velocity. You have to find the velocity of wedge when block m reaches to the lowest point. Right? So listen one thing. In this case, when it reaches, it will move backward like this. Are you getting? It acquires some velocity and it acquires some initial velocity. Right? This is the thing. So by conservation of momentum or by conservation of energy, conservation of initial momentum, it is at rest initially, everything in x direction I am considering, right? In x direction, what is the final momentum u turn? If you assume this is the positive direction, it is m v1 minus capital M v2. So in x direction, apply the conservation of linear momentum because no force acting in the x direction. So initial momentum in x direction is what? Say 0, and the final momentum is this. Implies that mv2 is equal to m into v1. Question number 1, right? Okay, this is the one relation we are getting from the conservation of momentum. Now we can apply conservation of energy. Conservation of energy. What is the conservation of energy? When it fall down, it comes down, it acquires some speed with respect to ground. This figure is with respect to ground. So it has some kinetic energy, from where this kinetic energy comes. So the kinetic energy comes from the potential energy. The decrement in the potential energy, what is the H, say is equal to R. The decrement in the potential energy of the block is converted into kinetic energy, right? But we have to find V2. So from here, the V1 is what? The V1 is, I will put, so this height we have to find. Simplify. This is the capital M, right? Small m is multiplied, this is capital M. Right? So this is the speed acquired by, this wedge when this reaches to the lowest point. Understanding? Copy this. Can you read the question number 8 now? Okay. So just before the explosion, what is the speed? Its speed is 100 root 3 by 2, right? So this is equal to 50 root 3. Are you getting or not? So before explosion, it is moving with speed, right? V, U you can say, and the U value is given as 50 root 3 meter per second. You understand or not? You tell. Right, this is 100 cos 30. At the highest point the speed will be u cos theta, right? So this is u cos theta. Now when it reaches, it explodes into two parts, right? This is m and this is 2m. So it moves with the speed u. The lighter part move vertically upward with an initial speed 200 meter per second, right? So therefore its velocity will be v dash. Is it clear or not? That is the thing. Do you understand or not? Also, this is the initial picture and this is the final picture. So after exploding, this will be moving with v2. I'm writing this the v1. So although it is moving in the vertical direction, so I will apply the conservation of momentum here in the two direction, in the x axis and the y axis also, right? So before collision in x direction, before collision momentum and the final momentum in x direction after collision. you have to put it equal to 0, right? So what is the initial momentum? Suppose the mass of the body is 3m, so 3m into u, initial momentum in x direction. This m mass is moving just vertically, so the 2m mass into the v2 is the final momentum in the x direction. You understand this thing or not? Yes. In y direction, what is the initial momentum in y direction? Can you tell? Before explosion, the 3m mass is moving only in x direction. So yes, what is the initial momentum in the y direction? Say 0. Are you getting? All the 3m mass is moving in only in the x direction. And what is the final momentum? This is m into u, that is m into 200, and this its momentum is equal to minus 2m into v1. You understand this thing or not? You tell. Any doubt here? So therefore 2m v1 is equal to m into 200, v1 is equal to 100 meter per second. So this speed component is 100 meter per second. Now this speed component 3u upon 2 v2, and the v2 is 3u upon 2, 3 upon 2. What is the u? The initial velocity is 50 root 3. It is u, right? So 75 root 3 meter per second is the v2. Is it clear or not? So if this is v2 and v1, so what is asking the question? They're asking the speed of the heavier mass. So this heavier mass will be moving in this direction then, right? Like this. So this speed will be is the resultant of v1 square plus v2 square. All right. So the v is equal to what? Root over 100 square plus 50 root 3 whole square. Sorry, 75 root 3 whole square. So 25 will come out. This is 4 square and this is 3 root 3 whole square, right? So it is 25, 16 plus 9 and 16 6 से लग गया 43 root 43 meter per second. Can you tell me the answer? What is the answer given? Okay, 100 degree मैंने गलत कर दिया. मैंने नहीं सही है. With vertical it is given. This is with vertical, so this is 50 only, right? Okay, now understood. So if this is 50, so what is this initial velocity? Is equal to 50 meter per second, right? So this initial velocity is just 50 meter per second. This angle 30 degree is given with vertical, right? So this is 25 into 75. So this is v2. So v2 is this 75 only, right? So this is 25, 4 square plus 3 square, and this is 5. This is 125 meter per second. Now answer you are getting or not? Right. And anything else the angle is also asked or not? Yes, copy this. In this question, what is given? The gas, the gun of the mass m is over there. Cell is fired, right? This is the mass m. So when it is fired, what will happen? The gun will recoil with the velocity v2 and the bullet will be moving with the speed v1, right? And the energy of the explosion such that as it would sufficient to project the cell. This is the shell and its energy. What is the energy? The energy of explosion is such that, okay, the energy as explosion, we are talking about the energy of explosion. What is the energy of the explosion? When it energy is explosion, so the energy we have to take the half m v1 square plus half capital M v2 square. I think so. And it is sufficient so that it may move to the height h. This is given. All right. The recoil velocity of the gun, m into v2, m into v1. So v2 we have to find. Is it clear or not? When the explosion occur, when there is no explosion, the kinetic energy and the momentum is 0. But when explosion occur, the momentum is again 0. Therefore, this is the equation. But the total system acquire some kinetic energy or some energy. So what is the energy after explosion? This, according to question, it is equal to the shell can go up to vertical height h. So this is the thing. So v1 is equal to what? M into v. So I will put here half m capital M upon m v2 square plus half m v2 square is equal to mgh. All right. So if I take v2 square by 2 common, so this is m square upon m plus capital M is equal to mgh, right? v2 square by 2 capital M I am taking common, m plus m is equal to mgh, right? Yes. Now we can find the v2, multiply, it become m square gh, right? And this is also multiplied, 2 is multiplied, m upon m plus m is equal to v2 square. So the first option should be the correct answer. Can you check the answer?